Hello everyone. Let's move to the next topic, that is Bitwise Right Shift. Um, right Shift looks like this. Okay, so how to work on them? Let's take an example for it. Uh, so I'm doing 12 is right shifted by 2. Okay, 12 is right shifted by 2. What this means, this is a little different from the left shift. As left shift is very easy, every bit will be shifted towards left. But to shift uh, values towards right, there is a little trick. Let me just make it a small change here, so it can be visible to you, unlike previous video. Sorry for that. Okay, so let's what will be the binary of 12? Binary of 12 will be 8 plus 2. This will be 10. No, we can consider 8 and 4. This will be 12. So let's put 1 below them and take 0 and 0 again. Okay. So double 1, double 0 is the binary of 12. What will the binary of 2? Obviously 1 0. So here will be 0 0 and 1 0. That's it. We have to shift it. So again, we not going to use the binary of 2. This particular statement says that shift all the bits towards right. Let's take a bit slot of 8 bits. Okay, whatever the bits are or whatever the binary of any number, just make it on or put it on 8-bit slot. Okay, so now what we have to do, we have to push it towards right. Okay, so how it will work, this 0 will be um, removed from here. This will be removed and will go forward and um, will be added here. Correct. Again, we have to shift it twice. Let me write it again. Okay, so when you do it first time, 0 will be removed and assigned towards the first value. So this is right shifted by 1. Now we have to do it twice. So let's remove these two values. Again 0 will be removed and both the 0 will be like this. Okay, so this is how the right shift works. Every bit that you use here will be removed from the right side. All the bits will shift right side and will come back here. Okay, so what will be the binary of double one? Binary of double one will be 3. Okay, you can just check it out. 1 and 1, add these two numbers, you will get 3. Okay, when you run this, you will get 3. Correct. Okay, let's move forward and take another value. Okay, so let me take another variable question. So if I write 1 2 or 22 is right shifted by 4, or let me change this to 27. 27 is right shifted by 3, for example. Okay, so let's calculate the binary of 27. What will be the binary of 27? Binary of 27 will be 16 plus 8. This will be 24. 24, 4 will not be considered. 24 plus 2, this will be 26, plus 1, 27. So double 1 0 double 1 is the binary of double 0 double 1 is the binary of 27. Okay, now we have to put it on 8-bit slot. So 5 bits are already here. Let's put 3 0 bits in front of it. So this is our 8-bit slot bit arrangement. Okay, So if you push it to the towards right, so every bit will shift towards right. So this one will be removed from here and it will be here. But there's a trick here. Um, when you push every value towards right, the condition here is when you, if there is zero already zero available here, the coming bit will always be zero. Okay, the coming bit will always be zero. Like here, it doesn't depend on what type of bit you are dropping here. All the values that are coming here will always be zero if this position, the starting position of the bit, is zero. Okay, so it's like uh, also if there is already one available, the coming bit will always be zero. So you have to check whether this bit is zero or one. So if the starting bit is zero, no matter what bit you drop here, the coming bit will always be zero. So the zero will be here, correct? We remove a one, sorry, just a second. So this is the binary of 27. When you shift it towards right, the one will be removed from here and go here. But as I said, it will depend on the bit available here. So this is zero. So zero will be forwarded. This one will be removed. Once you shift again, this is the first time we shifted the values. So if you shift it again, this one will again drop from here and it cannot come here. Okay, why? Because here the first bit is zero. Okay, so this will be the coming bit will always be zero. So this is the second time we shifted towards right. We have to do it 3 times. So let's remove this zero. Now here zero is dropping. So it doesn't matter what is dropping here. It all depends on this particular number bit. So here already zero is available. So it will zero will be added to the right. So this is the binary of 1 1. That is again this is a 3. So let's run this. It is giving us 3. Okay, so this is how it works. You can check one more question if you want. So I'm giving it to you. Just try it. So let's say if I take 47 is right shifted by 2. Okay, 47 is right shifted by 2. What this means? So let's take what will be the binary of 47. So it will include 32, obviously 32 will be added. So this is 1 plus 16. When you add 32 and 16, you will get 48, correct? You will get this will be 48, but we have to calculate for 47, so we cannot include 7. Okay, let's add 8 to it. This will be 40 plus 4, 44 plus 2, 46 plus 1, 47. So this is the binary of 47, 101111. Okay, 101111. This is the binary of 47. Now we have to put it on a 8-bit slot. So let's add 2 zeros here. So this is the binary of 47. Now shift it towards right 2 times. When you do it first time, so this 1 will be dropped from here. Okay, it will go here, but it depends on what type of value is put it here already. So here the bit is 0. So all the values that are coming will always be 0. Okay, so this is our next value. So let's move forward. So when you, just a second, I did a mistake, I think. When you do it for the first time, it is right. Okay, so if I do it for the second time, the 1 will be removed, dropped from here and go towards this, but here already 0 is available, so the coming bit will always be 0. So we moved them towards right, shifted them towards right. So the binary is 1011. 1011 is the binary of 11. Okay, so you can calculate like this: 1 0 1 1. So 8 plus 2, that is 10, plus 1 11. Okay, let's run this. The output is 11. So this is how right shift operators work. Okay, let's move on to next topic.